This is part 2 of the Pocket NC Impeller tutorial. If you're not already in Fusion 360's CAM environment, migrate there now using the Change Workspace tab. Before we can create any toolpaths, we need to set up the stock and the machine's initial orientation. This is done by creating a new setup. To create a new setup, select Setup, then New Setup. The first thing we will need to do is change the orientation of the table, vise, and impeller so that it matches the orientation of the Pocket NC. To do this, select Orientation, then select Z and Y axis. Fusion will now wait for the user to select a line on a piece of geometry that is parallel to the Z axis. Once the Z axis has been selected, the user can immediately select the Y axis. At this point, the orientation of X, Y, and Z is correct. However, the origin still needs to be changed. To do so, select Work Coordinate System Origin, then select Selected Point. Choose the pink dot that represents the center of rotation for the A and B axis. Next, we will need to select all the parts of the model for machining. Once that is complete, we can select all the parts of the fixture. The last step of the setup will be inputting the dimensions of the stock material. To do so, select the tab labeled Stock. Because we know the size of our material, we can choose the mode to be Fixed Size Box. The impeller will be machined from a 1.5 inch cube, so the X, Y, and Z can be set to 1.5 inches. Last, we will need to change the Y negative offset to about 0.8 inches. If we were making this part from a harder material, we might consider using more stock on all edges to ensure the end mill not plunging into the part. We can now see that the stock material looks correct. The excess material is set between the gripper jaws so that only the teeth are engaged. We will now need to import the Pocket NC tool library. This can be done by selecting Manage, Tool Library, Cloud, and Import. Migrate to the file path of the tool library downloaded from the Pocket NC webpage. To generate your first toolpath, select 3D Adaptive Clearing. By turning off the filters, you will be able to see all of the Pocket NC tools. Select tool number 10, 1/8 inch single flute. As you can see, the cutting, lead in, lead out, ramp, and plunge feed rates all need to be changed. 30 inches a minute will work just fine as we're cutting pine. Within the Geometry tab, we will need to change the tool containment boundary as well as the tool orientation. To add the containment boundary, select Machining Boundary and Selection. We will want to keep the tool inside the boundary. Select the containment boundary after selecting the tool orientation. We will now need to change the orientation of the machine for the individual machining operation. To do this, select Tool Orientation, then select Z-axis and Y-axis. Fusion will now wait for us to select one of the 7 segments to orient the Z direction. Once the Z segment has been selected, the Y segment can immediately be selected. Now that we have the proper orientation for the tool operation, we can select the tool containment boundary for the operation. To do this, you will need to make visible the sketch which represents the first containment boundary. After the boundary is selected, we can move on to heights. While containment boundaries aren't always necessary, they're an easy way to keep the tool in a specific area. The only height we will need to adjust is the bottom height. To do this, select the plane, then select the offset and bottom height, and change it to about 0.8. By adjusting the bottom height, we have made sure that the tool does not extend past its cutting flute. You can also adjust the clearance retract, but it's not necessary. Next, we will need to adjust passes. I'm going to change the tolerance to about 1,000th. The optimal load for pine is about 80,000 step over with about 50,000 step down. Next, change fine step down and stock to leave to 25 thousandths. Next, change smoothing to 0.001 inches. The linking tab is the last we need to change. Within the linking tab, change retraction policy and non-engagement feed rate. Once the first toolpath is done compiling, be sure to check the underside of the impeller to make sure the tool does not remove all the material. As you can see, the cutter will only travel a little bit underneath the impeller. This will give the impeller something to stand on while we machine the rest of it. To make the remaining 6 toolpaths, we can copy the first toolpath and edit each individual copy. To do that, select the toolpath, select Copy, hover the mouse over the Setup, right-click, and select Paste. To edit the new toolpath, right-click and select Edit. We should only need to edit the Geometry tab. Within the Geometry tab, edit Machining Boundary as well as the Z-axis tool orientation. Last, change the rest machining source to previous operation. As you can see in Adaptive 6 number 2, the toolpath does not machine extra material where the material has already been removed from a previous operation. At this time, create the next 5 toolpaths for the remaining 5 segments. Now that all 7 toolpaths are created, we can do a quick look and make sure that all the toolpaths look correct. Be sure to check several angles and be sure that the depth does not exceed that of the cutter flute length. Now that the 7 roughing toolpaths have been created, we need to make 7 finishing toolpaths. These toolpaths will be from the same angles as the first 7. To create your first finishing toolpath, select 3D, then Parallel. Within the Geometry tab, the only changes you will need to make are to rest machining and tool orientation. Follow along as I make these changes. The only change I will need to make in the Heights tab is to the bottom height. Again, I will use 0.8 inches. Within the Passes tab, make changes to Tolerance, Step Over, and Stock to Leave. Within the Linking tab, change Retraction Policy to Minimum Retraction. When you've completed the first parallel finishing toolpath, use the copy-paste strategy to create the remaining 6 toolpaths. Now that all toolpaths have been created, we can select any individual toolpath and create G-code for it. To do this, select toolpath, select G1 in Actions, and select the Pocket NC post processor. End the name of your toolpath with .ngc. This is the file type that the Pocket NC recognizes. Once you've saved your toolpath, Fusion will load the program brackets. This allows you to make small edits within the program. We don't need to make any edits, so we can go ahead and close the program. Large programs take longer to load with the Pocket NC. To check each individual toolpath for its size, you can simply click the arrow next to the toolpath. This concludes part 2 of our 3-part first part series. Thanks for watching.